regular polygons. First, we have some definitions here. A regular polygon are polygons that have congruent sides and congruent angles. So they match all the way around. It says here you can inscribe any regular polygon in a circle and find the measure of their central angles. Okay, so here we have a square. We have a 1, 2, 3, 4, 5, 6 hexagon, and we have a 1, 2, 3, 4, 5, 6, 7, 8 octagon. And this angle here is called the central angle. Okay, let's talk about circles and polygons. So, if we inscribe with a circle around the shape, put this shape inside the circle, either way you look at it, we have the center of the polygon, which is the center of the circle. That angle, which we just talked about on the first page, is called the central angle. It's the angle formed by two radii drawn to consecutive vertices. Okay? Consecutive means the next one. So here's a vertex right here, and here's a vertex. Okay, and you get that by doing 360 degrees, because that's what's in a circle. And if you think about it, if you turn around in a circle, you turn 360 degrees, divided by the number of sides. So 1, 2, 3, 4, 5, which also is 1, 2, 3, 4, 5 vertices. So when we do 360 divided by 5, we get 72. The radius, as we know, is the distance from the center to a vertex. On a circle, it's just the edge of the circle. But in a shape, a polygon, it's got to go to one of the vertices. And then there's this new thing called the apothem, or apothem, depending on how you pronounce it. It's the perpendicular distance from the center of the polygon to a side of the polygon. So, we have a new formula. The area of a regular polygon is 1/2 times the apothem times the perimeter of the polygon. So, for example, we're going to find the area and perimeter of each of these shapes. Well, remember, if it is a regular polygon, each of the sides is 4. So right off the bat, we know the perimeter is 4 times 3, 12 feet. Or 4 plus 4 plus 4, 12 feet. Now, we also need the apothem. Okay, so now we're going to kind of put everything together that we've been doing for the last few chapters. This goes back to chapter 6. So we're going to use it all. So, as we imagine this was in a triangle, the triangle's in a circle, and we drew that, this would be our central angle, right there. Okay, and to find out what that is, we take 360 divided by 3, which tells us 120. So the central angle is 120. We're going to drop down our apothem, which would make this 60. Here we have 90, and here we have 30, and so therefore, what do we have? A 30, 60, 90 triangle. Now, there's not a lot of room here to fill in, so if each side is 4, we know this is 2 right there. And that is the long side, opposite the long side. So to find the apothem, which is the short side, we need to do 2 divided by root 3. And then we rationalize. And that gives us 2 root 3 over 3. Or 2/3 root 3. So that's our apothem right there. So to find our area, we take 1/2 times 2/3 root 3, or we can separate it out like this, times our perimeter, 12. So you can write this together or separate, doesn't matter. Here we have the 2's cancel. And basically we have 12 over 3, root 3, or 4 root 3. And that is our area. It's going to take a little bit. We're going to do plain practice. We'll do plain this in class. So don't worry if this is kind of weird at first. It's all right. Okay, number 2. We're going to draw this out again. And we do 360 divided by 4, which is 90. So that central angle right here is 90. We're going to drop our apothem down, which makes this 90, and this is 45 and 45. So 7 is our hypotenuse. So we need to figure out what this is right here. Well, that's one of our legs. And the apothem is going to be the same measurement because it's 45, 45, 90. So we're going to do 7 divided by root 2 and then rationalize. So that's 7 root 2 over 2, or 7/2 root 2. So that's our apothem. Our apothem is 7/2 root 2, or even 3.5. That might even help if you think about it. If it's really 3.5 root 2, that's right here, we actually need another one here. So each side is actually 7 root 2, and we need that to find our perimeter. So the perimeter is the one side, 7 root 2 times 4, or 28 root 2. And now we calculate our area is 1/2 our apothem, 7/2 root 2, times our perimeter, 28 root 2. And now we just multiply it all out. Okay? So we do our outside numbers. So we do 7 times 28, and then divide by 4, or, since we know 2 times 2 is 4, and 4 goes into 28 7 times, that gives us 49 times. Root 2 times root 2 is 2, so the area is 98. In this case, it would be units squared. I've got my units squared over here. Now again, that may be confusing, and if you want, you can fast forward to the next problem, or you can go over this a little bit more. So if you want to see it again, I could have done, 1/2 times 7/2 times 28 over 1. All I did was cancel my 2 into my 28. So this goes into this 14 times, and this goes into that 7 times. That's one way of looking at it. Another way is actually multiplying. And you could have done 7 times 28, which is 196, over 4, which again is 49. So there's a few different ways you could look at that. And then times the 2, which is the radical 2 squared, and that gives us our 98 units squared. There's our perimeter right there. Moving on. root 3. So we get our central angle here, again right there. So this is 360 divided by, how many sides? 6, the hexagon. So that's 60. So when the apothegm is there, that makes this 30, this 60, and there's our 90. This is 5 and 5. So 5 is our short leg. So our apothegm is actually 5 times root 3, because our apothegm is our long leg. So our perimeter is easy. Perimeter is 10 times 6, so that's 60. And we have meters there. I guess I was wrong, sorry. These were feet squared, and this was inches squared. And this was inches. Sorry I missed that. Okay, so 60 meters for our perimeter. Then our area, we have what we need, 1/2 times our apothegm, which is 5 root 3 times 60. So whatever way you want to do it, 1/2 of 30 is, 1/2 of 60 is 30, times 5 is 150 root 3 meters squared. That's our area. Oops, 150. Lost my 0. Number 4. Now this one's a little trickier. It's kind of a challenge problem. This is an octagon. So 360 divided by 8 is 45. So when we cut 45 in half, so I'm going to actually come over here and make it a little bit bigger. This is 22.5 right here. We don't have any quick ways to do an angle like that. It's not 30, 60, 90 or 45, 45, 90. So we know this is 8. We're looking for this side. We go back to unit 7, and we're going to say the sine of this side is, the tangent of this side, opposite over adjacent. So tangent is, 22.5 is x over 8. And then we're just going to multiply 8 times the tangent 22.5. And we get x is equal to approximately 3.31. Which makes each side 6.62. Does that make sense? This is 3.31, right here. But we have to write it twice to get both parts. That gives us 6.62. So our perimeter is 6.62 times 8. Okay? So perimeter is 6.62 times 8, which is 52.96 inches. That's our perimeter. Our area is going to be 1/2 our apothegm, which we know is 8, times our perimeter, 52.96. That gives us an overall area of 211.84 inches squared. So it's not really hard, it's just putting together all the things we've learned this semester so far. All right? So here's number 5. We're almost there. Again, we draw this out. It is a hexagon again, so that means the central angle is 60, which means this is 30, that's 60, and that's 90. Again, 6 is our long leg, so to find our short leg, our apothegm is our long leg, so that's 6 divided by root 3, we rationalize, and that's 6 root 3 over 3. So that's 2 root 3. And that's just for this section right here, which means the entire side, each of these sides, is 4 root 3. Therefore, our perimeter is just 4 root 3 times 6, or 24 root 3. And then our area simply is 1/2 the apothem, 6, times 24 root 3. So 1/2 of 6, 1/2 of 6 is 3. 3 times 24 is 72 root 3. And that's meters squared. This is meters up here. Okay? 72 times the square root of 3. Okay. We have another tricky one here. Our center is right here. We drop down. This is 90. All right? And if you see this, all these are 90, obviously. And the diagonals, remember, in a square bisect the angles. So this is the 45, 45, 90 triangle. So if the diagonal is 10, that makes this section 5 and this piece 5. Now 5 is our hypotenuse. We want to find the leg, which is also our apothem. So what do? We divide by root 2. And then we rationalize, like we always do. And that gives us 5 root 2 over 2, or 5/2 root 2. Well, 5/2 root 2, or another way to look at it is 2.5 root 2. That's 2.5, not 2 times 5. That's just this section right here. We need to double it, and 2.5 doubled is 5, so the entire side is 5 root 2. Therefore, the perimeter is 5 root 2 times 4, which is 20 root 2 inches. And now our area is going to be 1/2, 5/2 root 2 times 20 root 2. Okay? So again, we have our math here. We have 1/2 times 5/2 is 5/4. We do 5 times 20, which is 100, divide by 4, which is 25. So that's 25 times root 2 times root 2, which is 2, so that's 50. So the area is 50 inches squared. Okay, 2 more left and we're done. So it's a triangle, which means 360 divided by 3 again, which is 120, which makes this 60, and that makes this 30. So 8 is our short side. Our long side is going to be 8 root 3, which makes this also 8 root 3. So our length of one side is actually 16 root 3, making the perimeter 16 root 3 times 3, which is 48 root 3 feet. Now, we're ready to go. Our area is going to be 1/2 the apothem, which is 8, times 48 square root of 3. Well, 1/2 of 8 is 4. 4 times 48 is 192 square root of 3. hope you're seeing it's not as bad as it started off to be. Okay. Again, we have a pentagon, 5. So 360 divided by 5 is 72 degrees. There's actually 2 ways to go about this. So if you want to watch both of them, that's fine. If I drop this down, this is 36 degrees right there. So I need to find x. I have my hypotenuse and my opposite, so I can do sine of 36 equals opposite over hypotenuse. And if I do 8 times the sine of 36, so sine of 36 times 8, okay, if we did this, that would give us x. But then we'd have to do it all over again with cosine to find, let's say, y right there, and then do it all over again. So we can do that. That's a lot more work. But I'm going to show you a quicker way with something else we learned. We also learned the area of a triangle using sine. So if this is 72 degrees, and this is also 8, remember the area of a triangle formula we learned. 1/2 both sides times the sine of 72. And if we do that, it's much quicker. We end up with 152.17 centimeters squared. That's our area. Well, I guess we still have to do the other way to find the perimeter, so let's go back and do that. Sorry. So it's really about the same amount of time. So if we take our triangle again and do what we started with, sine of 36 equals x over 8. Okay, that's going to give us this length right here. So we do 8 times sine of 36. That's 4.7. So this length is 4.7, which if we double that, that means each side is 9.4. So to find the perimeter, we do 9.4 times 5. Which is 47.02 centimeters.